Almost all urinary bladder cancers are urothelial cancers. What does that mean? Well, if we have a quick look at the cells of the bladder under the microscope and how they're arranged, all will become clear, honest. So this is what we're talking about. Kidneys, ureter, bladder, urethra. So the urine is made in the kidneys, runs down the ureters and into the bladder. So any organ, any tube, any tissue up against urine is lined by a urothelium, which is a specialised form of epithelium. It's a form of transitional epithelium. And we can actually see the layers of the tissues of the bladder. We can see that urothelium on the inside. You can see that it's folded, which allows it to stretch when the bladder fills with urine. And we can see a muscle layer, and we can see a hint of a connective tissue covering as well. So those are the layers that we can look at under the microscope. So the urinary bladder is a muscular organ. Its job is to store urine until it is convenient to expel it. And that nature of it being a muscular organ, we saw that the ureters are muscular tubes last week, means that when it empties, it doesn't rely on gravity. It can squeeze the urine out to empty itself properly. And these are smooth muscle cells, so they are autonomic, not something you have control over. You do have control over your intra-abdominal muscles because the muscle wall is skeletal muscle, so you can, you know, force the urine out by increasing the pressure. Anyway, here's our tissue. As you can see, it's just a segment of the bladder wall. It's just a little piece of it. Okay, let's have a look at these layers. Oh, Masson's trichrome again, lovely. So most of the cells are pink and purple, but we can see the connective tissues are in green. How's my focus for you? So up here, that's the lumen. So the bladder, of course, is this sac, almost a conical sac when relaxed. And when you've got about 200 millilitres of urine in your bladder, you're kind of thinking, quite like to empty that. When it gets to 400 or 500 millilitres of urine, you really want to empty it. So the urine is up against these layers here. So the layer closest to the lumen, closest to the urine, that's the urothelium, that's that specialised epithelium. The green layer then is the connective tissue. Oh wow, we've got some beautiful marbling there with some reds. So the connective tissue there is also filled with blood vessels, which is what we're looking at, and that's supporting the urothelium. And then we've got muscle, 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 and then a bit more connective tissue on the outside. And that's it. That's the bladder. Let's zoom in. So this is my 10 times objective. It's very cool looking, isn't it? Yeah, so the epithelium near the surface then is we can see there's multiple layers, so it's a stratified epithelium. But this urothelium is very special in that the cells have got different shapes. Let's go up another power. Slightly different jobs to do. And they're stretchy. Is that a bit bright? So the cells of the urothelium are stretchy. We saw on the model that the inside of the bladder is folded, and that's one of the tricks the body does when it needs to stretch. Instead of properly stretching, it folds, which can then be flattened out as the bladder fills to stretch it. But the cells of the urothelium here, they're quite fat, and when the bladder fills with urine and this layer needs to stretch, these layers go from being fat to being thin. They become a squamous cell shape, which is amazing. And the green connective tissue we see underneath is, it's not just full of collagen, but it's got elastin in there, I think. So it's a stretchy connective tissue. And we can see some of the blood vessels in the next layer. Let's do this layer by layer though. So let's get up close. So now this is my 40 times objective lens and my 10 times eyepiece lenses, giving me 400 times magnification. But right, so there's our urothelium. It's multiple layers of cells. Now the cells closest to the green, so the deepest cells, the basal layer, these are stem cells. So just like other epithelia in the body, the cells closest to the urine are going to get lost. Just like, so our skin is covered in an epithelium, right? And the surface layer is continually lost, and cells deeper make new cells which come to the surface which get lost. So this epithelium is always continuous. Same thing inside the bladder with the urothelium. The basal cells are stem cells producing new cells, and the cells at the top are lost. Now the cells in the intermediate layer, these tend to be great at proliferating. Oh, we can see some blood vessels right up against the urothelium there. Oh, that's a bit thicker. So the cells in the middle, in the intermediate layer, are great at proliferating. So we see lots of cells in there. Maybe you can see a bit of a cell shape difference. The cells closest to the urine are called umbrella cells or apical cells. We're maybe getting a sense of that there, because often one umbrella cell they're a bit wider, so they stretch over two of the intermediate cells. But they give often a characteristic appearance to a urothelium of kind of domes on the surface of the urothelium. And those are the cells that are really important. So the umbrella cells closest to the urine, closest to the lumen, are stuck together really tightly, I think with tight junctions and adherens junctions. The urine contains things that you're trying to get rid of, stuff that you want to excrete. And the kidneys have done a very careful job of taking out the water that you need to get rid of, and taking out the salts that you need to get rid of, and keeping the things you need and putting them into the urine. So you don't want the fluid and the salts and the molecules in the urine going back into the body. So this layer here is very, very tightly forming an impermeable boundary that tries to stop anything in the urine going back into the body. And that's why they're so special. And like I say, as that layer gets worn away, cells from underneath come up and replace them. Now, if you think about it, the toxins in your body, you're trying to get rid of them by excreting them in your urine. And that urine passes into your bladder, and then it sits in your bladder for a little while. So there's a bit of a problem here. If you've got toxins that can damage cells, they're up against these cells for extended periods of time. You can have urine in your bladder for hours and hours and hours. So if you're, so people that smoke and those toxins go into the body, this is how those toxins get removed from the body. A lot of them go out in the urine. So those toxins are then in the urine up against these cells. If you're working in a job where you work with harmful or toxic chemicals, and those chemicals get into your body, again, your body might be very good at expelling those chemicals, but it's going to put them in your urine, and they're going to sit next to these urothelial cells for a long period of time. Can you see how this can damage the urothelial cells, damage the DNA of the urothelial cells, and this is what leads to bladder cancer, right? This is why bladder cancer is a thing. So health and safety at work in terms of managing chemicals and stopping them getting into your body, it's those long-term effects that we're worried about. In that when you're young, you feel invincible, you don't really worry about these chemicals, I'm fine. 30 years down the line, those chemicals might give you bladder cancer. Yeah. So this is the urothelium. It's an epithelium, a form of transitional epithelium, an epithelium in which the cells are actually stretchy and can change shape as the bladder fills and stretches the walls here. And the most important job of the urothelium is to form an impermeable barrier so that the water and chemical molecules in the urine can't pass from the urine back into the body. And because the urothelium is lining all urine transmitting and collecting structures, inside the urine collecting spaces of the kidney, ureters, bladder, urethra. That's all urothelium. Urothelial cancers can come from any part of that urine pathway. So that's all a urothelial cancer is. Now, urothelial tumours, so if a tumour does grow from this urothelium, it might be benign. It might not be a problem, just a little bit of a growth, a little bit of a polyp. The sort of thing, I think, you know, it can happen in response to damage and inflammation probably, but some growths of urothelium are just forming benign shapes. It's the ones that can spread around the body which are dangerous. But the urothelium then, as I said, is supported by, there's the urothelium, it's supported all the way along by this lovely connective tissue that's stained so beautifully in this section, and this is the lamina propria. And we've been looking at tissues throughout the body, and we're often seeing where we find an epithelium, we find a lamina propria next to it. So the lamina propria is the connective tissue that's supporting the epithelium, and we can see blood vessels in there. There's one right in the middle there, and we can see some little red blood cells in there. So we have some small blood vessels in here, and as we slide out a little bit, we're also seeing some blood vessels there as well. Now, are these... So, the muscularis mucosa is a smooth muscle there that we sometimes find in the lamina propria. So a mucosa is epithelium plus connective tissue. And this is staining a bit red. Wow, that's a good blood vessel, isn't it? Look at that. There's some great blood vessels in there. So you can see how the lamina propria is carrying blood vessels to support the tissues here. Okay then, so there's the urothelium. There's the lamina propria, so that's the end of the mucosa. This gap here is an artifact of when the slide was made. The next layer here is muscle, smooth muscle. So there's a layer here, a boundary. Maybe if I jump back out, that'll be a bit clearer. There we go, urothelium, lamina propria, and then there's a gap there. That's just the layers of tissue have come apart when either it's been processed, when it's been dehydrated and stained and what have you, or during sectioning. But as we saw at the beginning, the rest of this is muscle. But can you see how, so we've got blocks of smooth muscle cells here, and the muscle fibres are running in slightly different directions. Can you kind of see that? Some of them are being cut through like that, and some of them are being cut through at an angle, and some are going around. So we're seeing lots and lots of smooth muscle, and I say smooth muscle because that's the autonomic muscle that we can't choose to control. Our autonomic nerves control for us, and this is the detrusor muscle. Wow, it's making some really artistic shapes in there. It's like modern art in here. So these fibres are running in different directions. So there are 3 layers of muscle with fibres running in different directions, because then that's how you contract like a sphere. When the bladder fills with urine, it becomes more spherical. So if you want to contract a sphere, you don't want to just squeeze it that way or squeeze it that way or squeeze it that way. You want to squeeze all ways at once to push the urine out through the urethra. All right. Let's jump out again. And look, so if I go back up, there's the mucosa, and then look, there's the, that a bit bright. There are the layers of the detrusor muscle of the bladder that the autonomic nervous system will contract to expel urine from the bladder. And as we get to the outer edge, then we're seeing connective tissue again. So this is the serosa. We usually find on the outside of organs, we find a serosa, a connective tissue. And the blue there is showing the collagen of the connective tissue. It's covered in a layer of cells, which is holding everything together. We might see some fat, but maybe not in this one. Oh, is that a... Now, correct me if I'm wrong, but that looks like some very big cells in there, in between the layers of muscle and muscle, right? Now, very big Yeah, very. When you see very big cells like that, they're neurons, right? What am I asking you? Yeah. I'm asking you because we've done this before. Huh, that's a cool finding. A bit brighter. Right, so these are neurons in the wall of the bladder. What, as in, these are the cell bodies of the neurons, not just the nerve endings. So what on earth are these? Well, these must be parasympathetic neurons, so post-ganglionic parasympathetic neurons, because sympathetic neurons and parasympathetic neurons, they have two neuron chains, right? So your pre-ganglionic parasympathetic neuron for the bladder has come out of the sacral spinal cord. Those processes reach in here, and the cell bodies of the post-ganglionic parasympathetic neurons are in the wall of the organ, as you often find, and then these are the ones that innervate the detrusor muscle and tell it to contract. You can tell how much preparation I put into these. I'm figuring out as I go along, but that's what that is, right? Right? It's this huge, ginormous cell. Look, there's another bunch here. This is literally what we mean by a parasympathetic ganglion, a collection of parasympathetic neuron cell bodies in the wall of the organ. That's fantastic. I have to remember this is here so I can show other people I'm trying to describe this. Sympathetic innervation causes the sphincter between the urethra and the bladder to stay closed. Parasympathetic innervation causes the detrusor muscle to contract and the sphincter muscle relaxes so urine can leave the bladder. And there are various reflexes. I'm going into lots of detail now, aren't I? But that's cool. I did not know that was there. So cool. Yeah. So this is all nervous tissue, by the way. These are the cell bodies, and imagine that we've only got a section through the tissue there, so in 3 dimensions the cell bodies would be extending out and below the slide. So over here, that wiggly stuff, those are the axons. Those are the processes coming from or going to the neurons. So we've got a nerve there, and postganglionic parasympathetic neurons, very cool. Look, and we can see over here as well. This is all nervous stuff, and blood vessels there squashed in the layers and lymphatic vessels. Yeah, so that's what. Yeah. Anyway, cool. That there looks very much like. Let me center it up for you. Sensory apparatus. In the skin, if we were in the skin, I'd say that would look like a Pacinian corpuscle. But that looks like a pressure receptor there. Wow, yes, that is a Pacinian corpuscle. That's amazing. You do get them in the bladder and internal organs. Oh my word, that is so lucky to find that. And of course, it makes sense that. I mean, it's really distinctive, right? It looks like an onion. You've cut through an onion, and of course, it's right next to the nerve. So a Pacinian corpuscle is a nerve ending surrounded by layers of connective tissue, and it's sensitive to pressure and vibration. You find lots of them in the skin. So in the bladder, less vibration, more pressure. So as those circles, as those layers there get deflected, so as the bladder fills with urine, this ball of layers of connective tissue gets squashed, and they press on the ending of the neuron right in the middle there, which triggers the production of action potentials. That's the neuron. The sensory nerve ending of the neuron right in the middle there, and surrounded by those layers and layers and layers of connective tissue. That's amazing. You don't know how lucky you are. That is so cool. Wow. I hadn't looked at this slide before this session. That's amazing. I love that. So there we go. That's what we're talking about when we're talking about... so there are different types of mechanoreceptors and chemoreceptors, but that's the sort of thing we're talking about. Look, it's a physical thing that can detect pressure. Very useful because, of course, you need to empty the bladder, because if it keeps filling up with urine, it will back up the ureters to the kidneys. The kidneys are very delicate and the kidneys will be damaged. And if the kidneys are damaged, you'll die, because you need your kidneys to balance the amount of water and salts inside you. Right. Superb. Wow. Whew. All right. So now you know the cells of the bladder and the layers of the bladder, the layers of the tissues of the bladder, so you know how it's arranged. If we go back out again, you can maybe appreciate the thicknesses. So there's the urothelium with the supporting lamina propria, and then here is all the muscle here. And you might have heard of a muscle invasive bladder carcinoma. So that means that the cells of the urothelium, if it's a urothelial cancer, they have grown down through the lamina propria and into the muscle down here. That's what that's referring to. It's referring to these muscle layers, the detrusor muscle. But that's it for the bladder. I think the more we look at tissues, the more similarities we find. And hopefully, by looking at the cells and how they're arranged, it becomes clear how everything works and what happens when it goes wrong. Yeah, urothelium, that's the key, I guess, with the bladder. Okay, now you know all about the microscopic anatomy of the bladder. 4 layers, urothelium, you know all about urothelium, lamina propria, connective tissue, muscularis propria, 3 muscle layers, and a serosa covering it up. So now you can understand what happens when things go wrong with the bladder. All right, I hope that was useful and pretty and interesting. See you next week.